Hello everyone, I am Vanshika Agrawal from Program Batch BSc, and today I am going to share my experiment with you all. So the topic of my experiment is translucency in liquids. As we all are familiar with the word translucency, and we also know that some liquids allow light to pass through them completely, whereas some do not. So let us investigate more about it. The aim of my experiment is to find out absorbance of different liquids to get an idea of their translucency. What is absorbance, you may ask? So it is a measure of capacity of a substance to absorb light. For this experiment, you need to know the following terms. Illuminance, which is the amount of luminous flux per unit area, and its SI unit is lux. And light intensity, which is the amount of light emitted through a unit angle, and its SI unit is candela. Now let us look at the procedure step by step. First step is download the science journal application on your device. Then open the lux meter on the science journal application, as we are going to need it for this experiment. Now open the lux meter and keep a light source over it. Now spot the light sensor on your device. For this, keep the device under a light source or in a lighted room, and then try to keep your finger near the front camera and spot the light sensor. Once you have spotted the light sensor, take a container which almost allows light to pass through it and fill it the liquid which you want to take readings on. Now keep a light source above the light sensor and wait till the readings are constant. And then, once the readings are constant, take the container and keep it over the light sensor. As soon as you keep the container with liquid on the light sensor, the readings will drop obviously. It will drop to some extent and then be constant. So, then we can record the readings thereafter. Now, some safety for this experiment to perform are: make sure that the light intensity of the light source is constant. So, I have taken it to be constant of 1 kilolux in every case. So we shall take equal volume of different liquids. I have taken it to be 200 ml for all the liquids. And we shall use the transparent container which does not make much difference in the readings, as I have mentioned earlier. And some variables which we will be needing for the formula coming ahead are I, which is for intensity of light source, I dash, which stands for intensity of light after it has passed through the medium. And the medium here is liquid. Now let us look at the observations. So this is the observation for colored water. So you see that the reading is constant till 1 kilolux, and then as soon as we keep the container, as soon as we keep the container at this point, we keep the container, the reading drops and again becomes constant. And this constant is 228. So we shall note this reading, and this is for colored water. Next comes oil. So we have readings for refined oil and pure coconut oil as well. So you see that the refined oil readings are, here the container is kept and here the container is kept. So the graph goes like this. The reading is constant to 1 kilolux, as well 1 kilolux here. It drops and then it becomes constant, and we shall record the minimum reading. So here it's 674 in case of refined oil and it's 292 in case of pure coconut oil. So you see the difference that pure coconut oil is more absorbing light than refined oil. Next is for milk. So milk, as we have seen three liquids till now, we say that the milk has absorbed most of the light and only 16 lux of light is remaining, and it comes to the light sensor. Next comes honey, and honey we shall see that the reading is constant to 1 kilolux here, and then here the container is kept, it drops and then again becomes constant to 32 lux. So we shall know the reading. Next, we shall convert lux to candela. Why? Because we have a formula which is called a Beer-Lambert law to find absorbance. So the formula says log to the base 10 I by I dash. We have discussed what I and I dash are. So as we have measured illuminance using lux meter, we shall convert it to intensity, that's in candela. So how shall we convert it? Using this formula, which says 1 lux is equal to 1 candela into steradian per square meter. So what is steradian? Steradian is nothing but a solid angle, so which is constant here, and square meter is nothing but the area of the light source, which is also constant here. So can we say that on dividing these two intensities, the steradian and the square meter square will get cancelled. So we shall easily put the value of 1 lux and 1 candela to 1 candela. So if we get 3.2 lux, we shall be putting it in intensities as 3.2 candela. So we can just replace lux with candela. That's it. So we have found absorbance for different liquids, and the log to the base 10 part of it you can calculate using any of the log calculators. I have also used log calculator for accuracy over here. So we get different results for different liquids, and the absorbance of water is 0.641, for refined oil is 0.17, and so on. So now let us compare the absorbance of these liquids. So we see that the refined oil has the least absorbance and milk has the highest absorbance. So water is somewhere in between, that is not that good absorber and not also emitting all of the light. And now what can we conclude out of it? So we can conclude that different liquids absorb different amount of light, and if we put them in descending order of their absorbance, we will get milk absorbs more than honey, water, coconut oil, refined oil, and so on. So what shall we evaluate after it? I was surprised when I got the absorbance of oil to be less than that of water, because I thought that it is somehow related with the optical density, but I was wrong. And also my results may go wrong due to shadow or due to shaking of the container, but I tried my best to get the accurate results and avoid the accuracy because of these issues. Thank you.